Hello, everyone, and welcome to this month's webinar on the Southwest drought conditions and resources. Thank you to those of you who rescheduled last minute for us. The Juneteenth holiday on Friday rescheduled this meeting to this morning, and we hope that it provides as useful information on this side of the weekend as it would have on the other side of the weekend. My name is Joel Lisenby. I am a Regional Drought Information Coordinator for the Intermountain West and Southern Plains regions at the National Integrated Drought Information System, for NIDIS. You can learn more about NIDIS over at drought.gov, and I invite you to go and browse around all of the data and information that's available there. This webinar series is produced in collaboration with the USDA Southwest Climate Hub, and I have Emily Elias on the call with us here today. And it's intended to provide a quick update of drought conditions across the Southwest, and also provide some information about some of the tools that are available to help you manage through these drought conditions. The next webinar will be, we'll take a more broad look at the drought, not just in the Southwest. We're going to look west-wide at the current drought conditions. And at the moment, that's scheduled for July 20th. There will be more information about that to come. To begin this webinar, I would like to acknowledge that the land that each of us is on today is the ancestral land of tribal and indigenous cultures, and I pay my respects to their elders and chiefs, both past and present. And I welcome all tribal and indigenous peoples who are joining this webinar with us today. The format of this webinar will be a presentation by our two invited experts, who are John Mayer and Noah Newman. I'll be introducing them later on, followed by a time for questions and discussion. With a group this large, we found that the Q&A goes much smoother if you'll please just type your questions into the question box, which in the GoToWebinar software, it's a little different from the chat box. You have two different options, the questions and the chat. Please use the questions box. And at the end of both presentations, we will go through those questions and give the presenters an opportunity to address all of them. The questions will be moderated by Emily Elias, who is the director of the USDA Southwest Climate Hub. This webinar, it is being recorded. Everyone is muted at the moment, and we will make the recording available on drought.gov, and we possibly will also link that to the Southwest Climate Hub website. To begin, I will introduce our speakers. I'll introduce one at a time. So we'll first hear from John Mayer. Sorry, I beg your pardon, John Meyer. I said your name wrong. John Meyer is a research climatologist with the Utah Climate Center and Utah State University. John specializes in numerical modeling for both weather and climate timescales, and he currently oversees the Utah Climate Center's operational forecasting model platforms. John is also the state coordinator for CoCoRaHS, which we're going to learn about later, and he serves as part of the Utah Drought Task Force. So with that, I'm going to pass over to you, John. I'm going to make you the presenter, and you can take it away.
Thanks, Joel. Hopefully everybody can see my screen. Joel, do we look all right?
Yeah, we can see, it's not quite in presentation mode, but we can see your slide that says NIDIS Southwest US Drought Update. Yep, now you're presenting. It looks great.
Excellent. Well, lovely to see everybody on this Monday morning after a quick holiday. So I hope everybody is starting off well their week. We'll initially show our current drought situation here, which to no surprise to anybody is featuring quite a bit of D3, D4 across the desert Southwest and the Western United States. So we'll be keying in on some of the recent conditions that the region has experienced, as well as some of the forecasts moving forward, both short-term and from a seasonal perspective. So 2-week total precipitation over the last couple of weeks. Well, it's been hot and dry, so we can see total precipitation across the region is about the bottom of the color scale, with just about all of the region experiencing less than 1/10 of an inch. And I'll note that most areas have seen zero precip. We almost need a new color for areas that have seen zero precipitation. On the right-hand side, you can see percent of average precipitation everywhere. Just about is experiencing less than 25% of normal over this 2-week period, which I do note is a historically dry time of the year as we transition from spring storms to the summertime monsoon circulation. So dry period in general, but we are incredibly dry relative to what we should already be anyway. So just a good contextual point of view there. There is much of the desert Southwest that is looking at a 0 precip month of June, which is very rare, at least up here at northern Utah. We've only had 3 years with 0 precip Junes in 127 years of records. So very incredibly dry throughout the entire region. 2-week temperatures, it's been the headlines all across the country. Everybody is really focused in on the degree of heat that we've had in the desert Southwest. Average maximum temperatures shown on the left here. You can see over that 2 weeks, some of the areas in California, Nevada, and Arizona have averaged triple digits for maximum temperatures, in some places over 105. So incredibly unprecedented temperatures for this time of year, and in some cases, some places are setting all-time temperature records. Salt Lake City hit 107 last week, tying their all-time record temperature. So incredibly unprecedented temperatures for this time of year, and the heat looks to continue going forward for the last bit of June as well. Looking at precipitation percentiles on seasonal and annual timescales, the last 2 months are shown in the upper left, and you can see a qualitative description of how we sit percentile weight. Driest is that sort of dark red burgundy type of color, and that's record driest over the last 2 months. Much of the region is sitting at below 33% of normal, and another significant swath of the region is below 10%. So just really, again, the late spring storms had just really never materialized. We didn't really move the needle at all for the last 2 months. For a longer perspective, over the last 12 months, dating back to last June, we can see just how dry the region has been. A huge swath of the region is at record driest levels, and this dates back to the late 1800s. So this is not a typical dry spell or drought that the region is seeing. This is historically unprecedented in the observational records. Temperatures over those same time scales over the last 2 months, much of Arizona, New Mexico, southern parts of the Nevada, Utah, Colorado area, and of course California has been running a little bit of a fever in the top 10% of the temperatures for that 2-month period. And looking back over the last year, it's been just a very hot year in general for all the seasons, with parts of California, Nevada, and Arizona experiencing record warmth as well. So a deadly combination of record heat and record dry, really fueling the ongoing drought that we're seeing continuing. Thanks to the recent heat and dry conditions, the last 2-week evaporative demand, drought index here, relating that to the typical drought categories, shows that we've really exacerbated drought over the last few weeks with those hot, dry, windy conditions. The figure on the right shows the change for those last 14 days, and so we can really see the recent modification of the drought, drawing a significant amount of evaporative demand off of the land surface. So exacerbating drought in those areas. A function of all of this, we tend to look at soil moisture to see what's happening at the ground level. And the great satellite observations of soil moisture at both the root zone and the soil, or the surface soil conditions, show again unprecedented levels of dry conditions. Much of the area is sitting between 5 and 2 percentile of normal conditions for right now. So we're about at the bottom of the scale. There's not much moisture left in these layers of the topsoil in the root zone. Very, very dry. Looking at some drought indices that measure some of the recent changes, as well as monitoring vegetative response to the stressors of the atmosphere. And we can see really not a lot of good news. The quick drought response index, which is looking at maybe 2 4-week type of conditions, so short-term rapid changes in drought conditions on the ground. And we can see the recent heat and windiness and lack of precip is really fueling an exacerbation of the current conditions of drought across the desert Southwest for just about everywhere in the region. Vegetation similarly is responding. We've peaked past the green spring, the green up time, which at least up here in northern Utah wasn't much of a green up at all, and I'm expecting that to be just about everywhere else. But we can see moderate, severe, and a few pockets of extreme drought in the vegetative response index. And I expect as we continue to leave the green up period of the late spring months that we'll continue to see the vegetative drought response index indicating severe and extreme drought conditions. Looking forward, what do we have on the radar? The 1 to 7 day precipitation forecast from NOAA is predicting not a great situation for just about the entire desert Southwest. It does look like parts of Colorado and New Mexico are going to receive a little bit of moisture over the next week, which is great news for them. Utah, Arizona, Nevada, and California is looking at little to no precipitation, and even where we do have some of those, maybe 1/10 of an inch of precipitation, the evaporative demand and the lack of soil moisture is going to mean that whatever does fall in those small numbers is really not going to contribute much to alleviating any impacts on the ground. 8 to 14 day outlooks from the Climate Prediction Center show, again, much of the region experiencing below normal precipitation probabilities, although they do have a pocket there of Arizona and New Mexico with above average precipitation probabilities, and that's a signal that the North American monsoon might be beginning to organize a little bit away from the central and northern Mexican terrain, bringing a little bit of moisture into the desert Southwest. So we'll hopefully see some of that 2-week outlook play out and bring some of that moisture to the desert Southwest. A little bit longer climate timescales for the seasonal outlook from the Climate Prediction Center. This is the 3-month or July through September outlook, and we can see the figure on the left shows temperature probabilities with the entire region looking at above normal summer temperatures being fairly likely at this point, which I think seems pretty reasonable given our recent spell of record heat. And then moving over to the figure on the right, this is our probability of precipitation outlook. And the northern periphery of the monsoon region seems to be locked into that dry section. So at least from the Climate Prediction Center's point of view, it doesn't look like we're going to get a lot of northern moisture plumes from the monsoon penetrating too far into the desert Southwest. They have equal chances for the southern part of the desert Southwest, Arizona, New Mexico, California area. So we'll have to see what plays out. The big question with these type of outlooks is where will the high pressure be to draw up that monsoonal moisture? And that's really the key factor on our summer outlook for the monsoon. Hopefully it's better than last year, and New Mexico shares a little bit of the monsoon moisture that they got last year with the rest of the region this year. So that's what I have at this point. So thank you. Sorry for more bad news. We'll be continuing to monitor the outlooks and hopefully see not as bad of news next time.
Wow, thanks, John. That was pretty bad news. I think you used the word, I lost count of how many times you used the word unprecedented. It's seems like it's so bad. It's just so bad that we haven't seen it this bad before. But thank you very much for sharing that news with us and sharing your time and expertise in telling that story. Our next speaker will be Noah Newman. Noah is a research coordinator at Colorado State University, and more specifically at the Colorado Climate Center. He is the Education and Outreach Coordinator for the Community Collaborative Rain, Hail, and Snow Network, or CoCoRaHS. Besides providing climate services to the public, he has been involved in climate education since the early 2000s and primarily works with students, teachers, and adult learners of all ages. Today, Noah is going to give a brief overview of CoCoRaHS and will be highlighting some additional features of the network that apply to drought monitoring. Now, Noah's been very busy promoting CoCoRaHS recently, including recording a podcast on a similar topic with Emily over at the Climate Hub. I'll drop a link to that podcast in the chat box, and I'll also include a link to that podcast in the post-webinar summary that will be available on drought.gov. So with all of that introduction, I think I need to give you permission to share your screen, Noah. So that's coming right now. And then as soon as you have that, go ahead and take it away.
Thank you so much, Joel. I really appreciate you guys inviting me. And similar to Emily, it was a real treat to be on that podcast. So thank you very much for that. As introduced, my name is Noah Newman, and I'm with the Community Collaborative Rain, Hail, and Snow Network, or CoCoRaHS. And I'm going to talk a little bit about what we are today, but also that we are more than just a precipitation network. So before I give a very brief history of CoCoRaHS, I'd actually love it if in the question and answer, if anyone can tell me if you've never heard of CoCoRaHS before. I take the assumption sometimes with groups like this that everyone has heard about CoCoRaHS, but I'd like to know if anyone in the audience has never heard of us before. And that's fine if you have or have not, but I'm not sure if I'm even able to see the Q&A. So if Joel, I'm not sure if you're getting any responses on that, but I'd be curious to know if anyone in the group has just specifically never heard of CoCoRaHS.
Well, we've had one person that says, please tell us about it. First time for another person.
Great.
So there's a couple of people who it's their first time.
Okay, yeah. Well, we've been around. We just celebrated our 23rd birthday, and we started out of Fort Collins, Colorado, from a 2-day storm that occurred in 1997. And the real bottom line of the storm shows up in this map, where these are not topographic lines, but actually precipitation amounts. And you can see the west side of town received nearly an entire year's worth of precipitation in this one storm. But back then, the airport, which was kind of the only official gauge at the time, really was only received about 2 inches of rain. And so had we had more people with rain gauges or some sort of real-time type of reporting, lives could have been saved, and that's how CoCoRaHS started. So out of Colorado back in 1998, when the project officially started, we are now 25,000 volunteers strong in all 50 states, Canada, Puerto Rico, the Bahamas. And the two main goals out of CoCoRaHS have always been to provide high quality precipitation data, but also to provide educational resources and outreach, which is my main job. So what does CoCoRaHS measure with precipitation? It's of course, the three biggies: rain, hail, and snow. And with CoCoRaHS, we use this rain gauge, and this is the one and only non-negotiable with the project. We want everyone to, in the end, do their best with where they put their gauge and how often they report. But the one thing that everyone needs to do is get this exact rain gauge, and it's modeled off of the co-ops, the National Weather Service's co-ops program, their 8-inch SRG, or standard rain gauge, and we consider ourselves kind of the farm league, or the recruiting grounds for what is the NOAA co-op program. But with that, with all of our stations, we have become the largest source of precipitation measurements. And many of the maps that John was just showing before, our data are integrated in several of those products already. So this is a way that you can get a gauge and set it up either in your backyard or where you work and help contribute data. When you submit your data, it goes immediately into our database, which then you can view on maps or tables. In fact, we've got a brand new map that is interactive. You can, this is actually showing just 1 week worth. So now you can set start and end dates and view accumulated data. And there's lots of options available on this map. So I highly recommend you go to our website and check out the map. As mentioned, the project really is all about detecting that variability. We've all seen it, where you look out the window and it's raining across the street and not on you. And so the more data we can have, the better we can understand this variability. This is an example back in 2008, and actually this is one of the times when CoCoRaHS first started raising the eyebrows of folks nationally on the value of CoCoRaHS, where one data point that actually looked like it was probably a typo turned out, just because of the person's one line of comments in their report really showed that they did have an extreme event, and the radar validated that, and it was a pretty big awakening that CoCoRaHS could really make a difference in people's lives. We also do hail, and with hail, I'll just briefly mention that the unique part of our data set that is unlike anything else that's recording hail is that we not only a lot of people will report the maximum size of their hail, but we're also having our volunteers report the minimum size and the average size, and whether it's clear or white, or you can submit all sorts of additional information that makes this data set very rich. And then there's snow data, and it's not just the snow depth, but also the snow water equivalent, as well as even the depth of snow on the ground and the snow water equivalent of that snow on the ground as well. The snow data are ingested into NOAA's National Operational Hydrological Remote Sensing group called NORISC, and it's definitely depend on our data. Many of their products include the CoCoRaHS data set. And then, of course, our snow data are also important to NOAA's river forecast centers, where they need to know how much water is kind of sitting up in those hills waiting to melt and fill up our rivers, which, as we know, this year has not been as good as we could really hope. But the main part of my talk is that we're not just precipitation, we're also doing other optional measurements too. We've got reference evapotranspiration, certainly not nearly as popular. This device is a little bit more expensive, but it's not using a calculated Penman-Monteith formula. Rather, it's a direct measurement of reference evapotranspiration. I don't even have a slide for it, but we've got a protocol for soil moisture as well, a gravimetric measurement where you physically pull out a plug of soil and cook it in an oven and do some weighing before and after to figure out how much water is in there as well. So we have soil moisture. We also do ice accretion. And recently we're getting serious with doing some major studies and refining our protocol. And this is not launched yet, but we're hopefully going to have a refined protocol where volunteers can put up a piece of wood or a dowel off of their rain gauge post and be able to measure ice accretion. Our real-time reports are quite interesting. Whether it's hail or significant weather that you're experiencing, you can submit a real-time report, which from CoCoRaHS gets routed from a system in the National Weather Service that will then route it immediately to your local National Weather Service office. So those real-time reports have made quite a difference over the years. But what I really want to talk about, and I'll finish my talk on talking about drought detection. And in the early days of CoCoRaHS, we started a protocol called drought impact reports, where we were encouraging our volunteers to submit impacts related to drought. And throughout the early years of this, it became apparent that we needed some refining to this protocol, because we were encouraging more just about drought and not talking about a person's overall conditions. And so a group out of the Carolinas, a NOAA RISA team, a Regional Integrated Science and Assessment team in the Carolinas, partnered with NIDIS and CoCoRaHS to develop a condition monitoring report that basically took our drought impact reports and made them more usable for NIDIS. And so we implemented a condition scale bar, and we kept the description and categories that one could check, but it really was about also doing some additional outreach and developing some regional guidance in each region where we could show monthly averages. We could encourage what types of things to look for. And we would especially encourage people to remember that sometimes the most extremes are really meant for that you're really not supposed to swing from one extreme to the other, and that over time, your measurements will be modulated based on your conditions as you get more in tune with your surroundings. And so now our condition monitoring map looks like this, and it has overlays of the NIDIS Drought Monitor drought categories. And it also, interestingly, we've got some toggle buttons where you can toggle on and off consistent stations. So that those stations that are reporting each and every week can be toggled on and off. Now, this is only a snapshot of 1 week here, but you'll see this analysis occurred between 2016 and 2020 with over 56,000 reports, all 50 states. And some data analysis can really be done with this. We've got some in-house tools with CoCoRaHS that do data analysis, where I pulled up Utah here for from 2016 through current. But CISA also did some neat data analysis tools as well. They created some story maps where using interactive, if you've ever seen these story maps produced, they're highly interactive. You choose your tab, you can scroll through, and for instance, they did some winter conditions here, frost freeze events. The previous slide here talked about flash drought. So it's become an extremely rich data set. And in-house, we also started doing some analysis of the Four Corners region. This is an interactive Power BI where I selected my categories and it just displays just those data points. You can dig into the actual reports. So it's become a very rich data set that can be used for drought analysis. And that is going to be the end of my talk. And if anyone has any questions or comments, concerns, I'll be happy to answer them. So thank you very much.
Thanks, Noah. That's a great presentation. And just so you know, in the question box, several people said they hadn't heard of CoCoRaHS before. So reaching a new audience, thank you for sharing. And you can order those gauges online if you're interested in joining the Citizen Science Network that has a really big reach, as Noah mentioned, 2,500 volunteers and counting. We do have a question coming in for John, and it's a question about the monsoon and whether or not and when the monsoon will occur. And it's where does the high have to move to in order to start the circulation patterns for the monsoon to occur? John?
Yeah, great question. I appreciate it. So the monsoon has already begun in Mexico. The Sierra Madres have already begun to exhibit their precipitation signals that tells us that the monsoon itself has begun to organize down there. We're right on the very front end of what we would expect the desert Southwest's monsoon season. Maybe the next week or two is historically when that area will begin to see their monsoon circulation organize. And it's a function of both these large-scale high-pressure patterns and these smaller-scale mechanisms that draw the moisture from the Gulf of California and Eastern Pacific up into the interior of the landmass. And for at least the southern half of Arizona and maybe a little bit of southwestern New Mexico, those small-scale processes are active throughout the season and do a pretty good job of bringing in moisture a couple times a week. The high pressure that we're talking about is really critical in drawing that moisture farther inland past maybe the southern half of Arizona and New Mexico. And for that to establish the circulation that we want that high pressure to be really centered over Colorado and maybe even Oklahoma. We want the western edge of that high pressure to be centered over the desert Southwest, and that draws up moisture into the interior. And so really the position of that high is what we watch. If that begins to shuffle too far to the west, then that moisture is not brought into the desert Southwest, and the storms of that region are really suppressed. If it gets too far east, like it did last year, again, the moisture is not drawn up into the desert Southwest. It's really skewed off. And last year, New Mexico got really the only monsoon that we had in the region, just because that high pressure was a little bit too far to the east. So it's a delicate balance. And if we get the high pressure that drops anchor and just sits in one really good place, we'll have a great season. And if it wobbles around, then we can really be susceptible to the variability of that in terms of when and where the moisture goes. Right now, based on the Climate Prediction Center's forecast, it doesn't appear like they're very confident that high pressure is going to set up in a place that draws up moisture too far into the northern edge of the monsoon region. We're talking northern Arizona, Nevada, Utah, and Colorado. So they're predicting a drier than normal monsoon season, and they'll be leveraging a lot of the position of the high pressure in their seasonal forecasting models. So if that hopefully answers your question. If not, drop another question in the question box. But excellent question.
Thanks, John. That's a great answer. A quick question for Noah. And we're nearly out of time, so this is a quick one. What's next in terms of CoCoRaHS and the CoCoRaHS network?
Oh, thanks. Great question. We are just plunging forward with continuing growth. We've got a lot of volunteers that have been with us for a long time, but it's always a matter of recruiting new volunteers and keeping going with the importance of using a manual rain gauge. The automated ones are helpful, but using a manual gauge, submitting data to CoCoRaHS has proven to be extremely helpful, and anyone else that we can get involved, please look into joining.
Great, thanks, Noah. This is our final question, and it's a question for John. Would most of New Mexico get our moisture from the Gulf of California or the Gulf of Mexico?
Another excellent question, and it can be both in certain circumstances. Again, really a function of where that high pressure is at and some of those smaller scale processes. So if the high pressure is a little bit too far to the west, then we can see New Mexico pulling up a little bit of Gulf of Mexico moisture. And that's a good moisture source for them, but really the best place is the Gulf of California and the Eastern Pacific. That tends to draw the highest amount of humidity into the region and contributes to the greatest monsoon seasons when we get that type of flow. But it can be a contribution of both. The Gulf of Mexico moisture tends to be a little bit more elevated in terms of where it's coming from and how it's getting to New Mexico. So it's not of a humid of an air mass when it comes from Gulf of Mexico. But yeah, both sources of moisture can play into their season.
Great, thank you very much. Thanks for that answer. I want to thank Joel Lisenby with NIDIS for organizing this webinar and keeping these going. We do try to keep them at half an hour. We try to do these every month. As he mentioned, the next one will be July 20th. Thanks very much to our presenters, John Meyer and Noah Newman. Thanks to you for joining. And also, if you have more needs, there's a Drought Learning Network available to link climate service providers with resource managers. And we know conditions are really severe right now. Please reach out to me or to Joel to find out more about that. This webinar will be recorded and it will be on the drought.gov website. You can also find out how to reach the Drought Learning Network there. And this concludes our webinar. Thank you for joining.